One of the most interesting places to look for buffer overflow vulnerabilities is in the history of malware. The possibility of input data overrunning the boundaries of a fixed size area of a computer memory has been known since 1950s. When computer first started storing data in random access memory, malicious software really didn't appear in public until the mid 1980s. And then only one of the many mainframe computers, but it soon spread to personal computers where proof of concept like malware were easier to develop in test. This movement of malware of personal computers like also gave birth to the antivirus software industry. Today we look back to see some of the most famous and memorable examples of malware in the past 30 years and that has exploited buffer overflow to achieve its purpose. So in the beginning, the Morris worm of 1988 was the very first significant malware event on the internet. This worm propagated across the internet using the three different methods, one of which was a zero-day buffer overflow in the Unix finder daemon. Finger is a Unix finder which used to obtain information about the user and the user accounts, and the daemon is a process that runs in the background on a Unix system on Windows. You know them as called now is services. The Morris worm exploited an overflow condition and a 512 bytes buffer, and that allowed the instruction pointer to be redirected to run the Bootcamp command, effectively opening reverse shell back to the attacking system and giving the worm access to the targeted system. Nothing much happened publicly in the way of buffer overflow vulnerabilities until the early 2000s. When the code red worm of 2001 suddenly appeared, and the code red worm was able to infect Microsoft Windows computers by exploiting a buffer overflow found in the Microsoft Internet, and the information server web server versions 4, 5 and 6. The vulnerability was where the IIS web server communicated with the indexing service in the IIS search engine, which was enabled in IIS by default. This exploited was reliable and allowed full access to the Windows server. Its existence was actually revealed by Microsoft as a patch to fix the vulnerability over a month before the code red appeared, and the code red was the first, and this could not only be reverse engineered to discover the vulnerabilities and they were mitigated, but also that malware could be crafted to effectively exploit that vulnerability. And the code red also demonstrated that recovery and restoration from a large-scale malware attack could host billions of dollars. And code red wasn't the only one to exploit this vulnerability by IIS, and the variants of the worm soon appeared and were dubbed as a code of red, code of blue and code of green as the different payloads and objectives. This was also proof positive that malware itself could be reverse engineered, reposed and redeployed with effectiveness. And this was also released by Microsoft and it about 2 weeks before. And the next Windows wormholes from the past, which firstly appeared as an IMDA in 2001. Then the next one was Volgimo in 2003, and the third one is SQL Slammer also appeared in 2003. and also Caesar the very next year appeared as a Windows operating system. So it doesn't just end here. The Microsoft Windows also occurred and decom the RPC interface button overrun. Also, Microsoft Windows Web Dev buffered the overflow, which LS and AS service overflow the system. And also, after the 2003 exploiting basically the same buffer overflow vulnerabilities in Microsoft Windows, firewall not running all processes with system level privileges and immediately applying security patches as they were release practices. We know today to be a no-brainer with the Linux and the Unix operating system have not been spread the presence of a malware exploiting buffer overflow vulnerabilities, either OMS and other malware seeking to run code and escalate. Privileges have attacked these symptoms like the system since the Windows natively spoke the TCP or IP today. This is still a concern because most of our Internet of Things devices that talks about the Internet runs the Linux or Unix operating system. If we were to continue moving forward through malware history, we would notice that the attacks using buffer overflow seems to be diminishing. We might expect that the increased awareness in computer and information system security and the use of proper coding and testing practices have all but wiped out exploited buffer overflow vulnerabilities. And looking at the dissembled working of modern malware such as Stuxnet, Duku, and Flame and CryptoLocker shows various sophisticated malware that do not use buffer overflow exploit at all. However, buffer overflow vulnerabilities are still out there both in very new and very old program releases, and modern malware is still exploiting them. So, for example, the Zeus banking intrusion first appeared in 2007. Although Zeus relies on social engineering to interact the system, but once installed it uses like a known buffer overflow flows like in Adobe product and Microsoft and ActiveX to steal like our bank credential and a username to perform a key logging on user input. And these 2011 and 2013 variants of Zeus continue to exploit buffer overflow vulnerabilities when possible. The heartbeat vulnerability, the SSL is an input validation error very similar to the type that allows buffer overflow to occur without the owner's knowledge or permission. Heartbeat is an excellent example of how the lack of simple input validation can create a buffer overrun vulnerabilities with potential severe consequences like privileges. The 0-day vulnerabilities have been present and exploited on most Linux systems worldwide for several years defenses, and that prevent a buffer overflow condition from becoming exploitable and have made this vulnerability much less of a successful attack and likes of vector. And nevertheless, the advance of persistent efforts will eventually find a way to any defense created to safeguard a flaw from attack.